So later on, hopefully you're seeing that if something has linear correlation, on some of the graphs, have you seen some lines drawn on those? Okay. The line that's drawn that kind of fits the data, we call a trend line. Now, you're going to see some other vocab for that later on. We also call it a regression line or a line of best fit. The best line, the trend line, we're going to eyeball. We're going to look at it. We're going to draw one. Your trend line might be different than mine. Okay? A regression line or the line of best fit is the absolute best one, and there's a statistical way to figure that out, and your calculator will do it for you. So these we'll learn later on. There's only one of. But trend lines, we're going to have to draw ourselves. So for the vocab, I'd like to say that a trend line is a line that models the relationship between two variables. A line that models the relationship between two variables. So today we're going to learn about something called a residual. That kind of seems like a fancy word, but they're really quite easy to find. A residual is a way that we can tell how close our line is to the data, okay? And so the definition of a residual is it is the vertical distance. It is the vertical distance between the data point and the trend line. And then I'm going to give you a formula. To find the actual residual, what we're going to do is we're going to do the actual point or another word for that is the observed value minus the predicted y value. And that's going to be the one on the line. So I have a question for you then. The closer that the line is to the points, what should happen to the residual then? If the line is closer to the points, what should happen to the residual? What would happen if you subtracted those two numbers then? What do you think? For instance, we're going to do one in a minute, but let's look at line A, okay? If it's perfect, do you see that the point is on the line? So what would happen if you subtracted those two numbers then? You'd get what? 0. So the further the points are away from the line, the bigger the residual is going to be. So if we want to tell which line is better, if I'm comparing two lines, you could find the sum of the residuals. The closer the sum is to 0, the better the line fits. The data. closer the sum of the residuals is to 0, the better the line fits the data. Okay. Has anybody seen these two words before? Extrapolation and interpolation? No. What word do you see in extrapolation? Extra. If something's extra, it's beyond, right? Okay. So extrapolation is when we use the trend line to predict beyond the data. Okay. And I have a nice little picture here in a second. Interpolation. That word inter means within. So this means you're going to use the trend line to predict within the data. Okay. Do you see the little dots? Do you see the first dot starts here and the last dot starts there? So let's say I asked, and then there's this line, and we would have an equation for that line. So let's say I asked you, hey, what's the, I don't know what the y is, what's the y value at 25? Do you see this is 20? At 25, that would be right here. Is that within the min and the max of the data? We call that interpolation. If I said, hey, predict what would happen at 70. Is 70 within the range of my data? No, that's over here. That's extrapolation. Or if I said, predict for 0. 0's over here. So extrapolation is not just above, it's also can be below. And interpolation means within the minimum and the maximum. Okay? Because do you see how these points are all scattered, but this line is still going to help me find an approximate value in between there. All right, so we're going to do a little bit of comparing lines. So with residuals. This is the, I don't know if you can tell, do you see that this is the exact same data? But two different trend lines are drawn. What we are going to do is we are going to draw residuals, and we're going to find the residuals, and we're going to see which one's better. So now, here, when we're doing this, we might have difference of opinion of maybe like 1 or 2, but they should be all around the same. All right, so the first thing we're going to do is we're going to draw the vertical distance, and then we're going to write them in. These are residuals, okay? So if I measured from here to here, vertical to the line, how far do you think that is? Well, but look at the scale, Donovan. Would you say 1 or 2? And is it above the line or below the line? Above. So if I did the data minus the line, it would be positive. I'll write +2, okay? How about this one? It's on the line. What's its residual then? 0. Okay. I have 2 over here. How about the one above the line? You want to do +2? How about the one below the line? Well, not -2, because this from 1 tick mark is 5, and it's more than 1 tick mark away. You want to call it 6 or 7. Also, it's below the line. So what would happen if I did this minus that? I would get a negative number. Agreed? Should we call it -6? All right, how about the next one? 0. Ooh, how about this one? I think that's pretty clear. That's 2 tick marks, right? Plus 10. Ian, if you want to put plus 8, I would accept that. All right, how about this one? Plus 2. And then how about this one? Minus 5. All right, you guys. Let's find the sum of our residuals, okay? So I'm going to write line A here. Can we do this in our head? Sum equals. Let's do all the pluses. Plus 2 is 4, plus 10 is 14, plus 2 is 16. Now let's do the subtraction. 16 minus 6 is 10, minus 5 is 5. In line A, the sum of the residuals was 5, okay? In other words, all of the distances came to a total of 5. That's how good it fits. If line B is bigger than 5 or bigger than 5 away, then it's worse. If it's closer to 0, then it's better. Let's do line B. All right, shout out some numbers here for me. Nope, that's not 42. The residual. What do you think? Minus 10. Make sure you do pluses and minus. How about this one? That looks like minus 10 again, doesn't it? I have 2 here. It looks like minus 5 and also minus 15, doesn't it? So I'm going to write minus 5 and minus 15. I really should squeeze them both negative. It doesn't matter where you put them as long as you put the plus minus. Are you guys with me so far? Stop me if it doesn't make sense. How about this one? This one though. Minus 2 you want? What? I think it's minus 5. Isn't it 1 tick mark? I mean, maybe you could say minus 4 if you think it's a little less. All right, Will, what about this one? Plus 10. Plus 5. That one? 0. Okay, let's do line B. Line B. All right. Well, I'm going to do positives first. What's 10 plus 5? 15. Okay. 15 minus 10. 5. Minus 5. 0. Minus 10 is negative 10. Minus 15 is negative 25. Minus 5 is negative 30. Which one is the better fit? Line A. Why? The sum is closer to 0. Don't say the sum is smaller because technically isn't negative 30 smaller? Okay, the sum is closer to 0. It could have been negative 2. If this was negative 2, line B would be better because isn't negative 2 closer to 0 than 5? Okay. All right. Using line A, tell what the slope and the y-intercept represent in terms of the data it models. All right, let's just go back and we're going to do a real general equation here. What's the y-intercept of the line? Look at the graph. Isn't the y-intercept 140? It is, but isn't it 140? Doesn't it look like 140? Yeah. Okay. Can you guys tell me what you think the slope is? About? Let's do it. Do you see what I'm doing right here? Down 1, but it's not really down 1 because what's the scale? It's not 2. Slope is down 5 over 10. Ooh, what's that the same as? Negative 1/2. Okay. And the y-intercept is 140. What would the equation for that line be then? Negative 1/2 x plus 140. Okay. And 140